going to start with revision of what we did last time, right? Yes. I want to see whether you guys understood what we did. I know you haven't started doing what we did in class, right? So can anyone tell me let's first start with unit vectors, the ones you did this way. What did you understand from unit vectors? Anyone? Come on guys, you did unit vectors, you must know your answer. Tyson? Mr. Tyson? Give your answer. You weren't here. You're in class. It is Monday or something. You guys did unit vectors, right? Yes,
unit vectors are the function of a vector.
Yes, as you said. Quick revision. Unit vector is nothing but a vector divided by its magnitude, right? Let's have a resultant vector R. How are we going to find the unit vector of vector R? As he said, it's the fraction of itself. There. Is this the first time you see this? Get it in class, right? This is how you find the unit vector. Right? Usually it's noted like these, right? But this is not the only way you can note or denote a unit vector, right? You can always note it as that. So now when we find it in the question paper saying find, we like to take, we don't say find the unit vector. Say find these, using this notation. That's a unit vector. And if you're going to write it in this notation, the moment you forget to put the head, we call it the head, or the copy, you are, right? Now here's one thing you need to know before you can do anything with unit vectors, because now you did exercise 2. The whole thing, the whole trick is to know one thing. Vectors in the same direction have the same unit vector. Are you noting it? Vectors in the same direction have the same unit vector. Let's say we have vector A, B, right? And let's say there's a force acting on the same direction as vector AB, right? And the unit vector of that force is given as the force over its magnitude, right? What they mean is, these can also be equals to vector AB over its magnitude, same unit vector. With that in mind, you can tackle an exercise. And don't forget, guys, we did scalar vectors. Should we do revision? Anyone forgot what's a scalar product? Anyone? Guys, let's think about it using the mechanics that we have, right? What is a scalar? Sir? Yes, I take that one. Anyone else? Did you all hear you? Anyone else? No one. Okay, let's do this so that everyone can have a clue or can at least give an output. We're gonna divide you guys into groups. I'll have group 1, I'll have group 2, group 3, group 4, 5, 6, 7, 8, 9, 10, 11, and 12 at the back. I have 12 groups. Group 2, right? It says, listen, group 2, when he says it, it means he's also talking for you. So before he answers, just tell him, hey, that's wrong. But then it's not about getting the correct answer, right? Group 2 says a scalar, it's a quantity that has magnitude only. What does group 12 say? Agree or disagree? Or any other comment?
Okay, good.
Yes, you?
Yeah, we agree.
You agree?
Just magnitude.
You guys? You agree, right? You did that in grade 12. Scalar is a quantity that has only magnitude. Vector has magnitude and direction, right? So whenever we're doing scalar products, right? What do you expect after the product? It's just the scalar quantity, right? And let's think about it. What is work done? Group 10, what is work done? Group 1, work done, yes. Work done on an object. Okay, what is work? Yes? Force and? This group is slipping. What is it? Work done is a force, a component of the force. Yes, sir?
So it's a force. When a force acts on an object and an
Yes.
object is the displacement of the.
You guys lost. Yes?
It's me.
No, they lost. They didn't raise their hand, so they
I'm
lost.
saying what done.
Yes.
It's only force applied on an object and the object moves in the same direction with the force.
Thank you. That's it. That's work done. And work done, what is the units for that?
What joules?
Joules. Is it a scalar or vector? Scalar, right? So automatically you can see where we're going with the scalars, right? Now let's open up on page page 10. Page 10. Page 10, we're going to do exercise 2. In less than 10 minutes. You already did it. You understood it.
What?
You understood it. Exercise 2. Yeah? You understood? Who doesn't understand exercise 2? I'm moving on. Yes, sir. Yes.
I don't understand.
You don't understand number 3. Let's do number 1. Since you already did, let's get one guy from a group who's going to do exercise 2, number 1. Let's get a new one. Oh, start with you. Number 1. Tyler. Tyson. It's for you. You guys are Group number 11. Number Okay, guys, those who are done with number 1, after you get the answer, just show me that the magnitude of that force that you got is 51. 51. Is 51. The force you just got. Yeah, you got it. Show me. But I want to see 51. If I don't see 51, guys, done. Left click. Like I said, from group 1 up to group 12, give your group points. I said it, group 1. What is this one? Group 1 says it's a. I'll take the first answer. Just say that like it. Going once, going twice, full to group 2, group 2. This one. Okay, no. Group 1 is group 2. This one is? Okay. Group 1 says it's a vector. And this one? Group 2, what are you saying? Group 2? You are clean. So group 2 is also here. Group 2 is also there. Group 3? What is that? Difference between this and that. What is this one? And this one? So you also agree with this one. Group 3? You agree. You agree to disagree. You agree. You don't want to disagree. If another group disagrees, you'll agree. That you disagree. We all get the picture here, right? Yeah. This is magnitude. This is the vector. What do we mean by the vector? It's the vector showing the components. Remember, your I, your J, and your K. Right? And your magnitude is just showing the magnitude of the vector without that. Right? Yes, sir.
So the vector is like points.
Yeah.
Oh.
The vectors is like points. Indicates, remember in mechanics, right? You had a force and you had to find its components, right? And you can also write the force in terms of its components, right? So now, that one, the V with the underscore or the vector with the underscore, simply indicates a force with its components. Now, when you see those absolute value signs, that's when you talk about the magnitude of that force. So we're clear on that. Now let's get to that exercise. Answers. Time up. Group 1, come on. You don't have it. Which group did I say must do number 1? Let's get number 1. Like I said, guys, let's get it. Let's look at the question now. Right? It says find a force. Someone is asking, no, it's not them. They're not asking that. No, someone is asking me. I can hear someone. It's not them. It's asking me, but then why are we told to find the force unless the force is given? So they're like, find the force. I'm not looking at their script. They didn't do that. They didn't do that. So they circled it. What? Yes, They didn't say that. They didn't. You can come and check. They didn't do it. They didn't do it. Right? Right? I'm not saying the question is not clear, but someone did it. It says, find the force, and it's just circle. The 51 Newton. Here's your force. Guys, the reason why I wrote that down was so you know the difference between the two notations. They said find the force, and they noted it like this. In vector form. Find the force in vector form. Right? In maths, we don't use words fully when you ask a question. The moment you see that, find the force F, and it's noted like that, it means in vector form. Right? They could have said where, instead of saying that with a force that has a magnitude of 51, they would have said where is 51 meters. They could have said that, right? They could have said that. But instead of saying that, to confuse you more, they said the magnitude. So now we want a force that has components. And group 1 should be done by this. Yes, no, it's not the answer. But someone did say, after seeing the statement, did say, here's your force. Right? Someone did say that. Maybe you didn't understand the question. Group 1, I haven't your answer. Or should we use the answer as an example? Group 1, we give us sorry. 1, 2, 3.
They're doing exercise
1. Exercise 2, number 1. Everyone got exercise 2, number 1. Guys, just got it. Oh, you just got in here. Help each other. Discuss it. Let's have number 2. Where is it? Let's get number 3. Don't take team with your group. Yes, sir. Okay, number 3. Going once, going twice, group 11. Going once, going twice. Are you done? Yeah? You're done. Let's have 2 number 3s. Let's have 2 number 2s. Let's give them a chance.
God doesn't know what to do.
Give number 1. Just number 1. The other groups, you got the answers. We'll take you guys as the judges, the memorandum. We'll tell whatever they're doing, they will rectify. We'll ask you those guys. It's daily.
We don't know. How to find it. How do you find it? Unless you give it 2 and you have to make it 7.
Can you sell it?
I'm not being the front man.
I don't know how to do it.
Selling it. This going to sleep. Okay, this number.
Someone else is gonna come.
No, but I don't know.
It's not happening.
I don't know. The force they make this. Let's just think about
And then put it through.
Yeah.
What you say? Listen. Can we come?
yes.
English, one number 1. Number 2. I did. Group number, what's the group number?
No, we're not selling.
They don't want to sell.
We do. Selling.
You don't want to sell.
We do.
Now we're combining group. Can you combine it? Guys, if your group is failing to get an answer, we combine the two groups. They want to be combined.
You right.
Half a point, half a point.
That's fine.
Number 1. Do you want to make it a dealership with them? Put it. Anyone else? Guys, number 1. The one and the So I'm assuming the guys at the back,
If they were asking for
they all know the answer. You are the judges. Give them time. How many minutes did you take to solve it? 2, 3, 5, 6, 10 seconds.
they've got the same problem.
Okay?
Find the force. Make the force yes or no? Nah, you must. If you can just, if you just tell me that, then I'll know how to do it. No, I don't have a reference. Don't have
That's right.
What? Can we we want the same thing.
Okay, guys, for number 2, while we're waiting for group 1, they're still thinking. While we're still waiting for group 2, group 3, you've just combined yourself with group A. While waiting for group X, still doing their thing.
I don't know what to do.
Okay, group leaders, can you give? I'm giving you the crown. Yes, sir.
Very calm.
Yes, sir.
Yeah.
I will put the answers on board.
We just worked out the magnitude and the unit vector. I don't know what the
That makes sense.
Guys, check, guys. There's people who are burning with fire, asking themselves, no, but why did you say the answer for number 1 is 51? No, I said show that it's 51. Now they're burning. How do you show it? How do you show it? Show it.
But now that
You guys just give me the answer.
don't need to do it. What is that?
Yeah. Okay, you guys are done.
This is correct. This is a
I
unit
can take it.
vector. This is a unit vector, but they've asked me for the
Can take it.
so the
Group. What is this? X. The combination. All the groups are done. Okay, they can take a seat. Yeah, the guys, the judges. Let's go to number 1. Let's start penalizing, because I know the judges, they like to penalize. Instead of quoting the correct ones, we look for errors. Okay, what they did first, they said, okay, it's fine. They said the unit vector of the force is going to be equal to the unit vector of the vector that is in the same direction as the force. By this statement, they just said the unit vector of this force is equal to the unit vector of let's write it dA, right? That's what you guys did. Okay, judges, that's when you guys come in, right? My judge there, all the judges. Penalize. Where? Where do you penalize? Oh, these judges. Yes, sir. Okay, let's give it. Wait. No, we penalize it there. Let's start penalizing there. Let's penalize step by step. Let's just take our reports from there. Yes, sir. Where did you study law? Good one. Start penalizing here. You say, right? And where? And start penalizing there. Because what is F? F is a variable in maths, guys. You can't just write F. Put the underscore to show that you're talking about the force. Right? And okay, now we have BA. Everything is fine on the left hand side. Or should we penalize you? Or not penalize it? Yes, please. Arrow on top of the BA. To show that it's a vector from B to A. So also here. So you guys lost a lot of points. Now, here. Yes, sir? Some judges are just cruel. It's fine. You know, don't use two different apps. If you use the capital letter one, use the capital letter. If you use the small letter one, use the small letter. So they just have to correspond.
If I use small letters or all my answers, I use small letters. Will I get penalized?
But let's see one thing. If I say solve for x, then you tell me t is equals to 5. And in my memo, x is equals to 5. Have you solved for x? So use whatever is given there, because that's what you're looking for. You answer. So, yes, sir? Anyone else? Okay, here we can all see. Right? So we're finding vector BA. Penalty is there. Right? For those underscores. The magnitude of vector BA. 17. Correct. The unit vector of BA is these. Correct. Right? Now if you want to find that force, it's going to be the magnitude of the force multiplied by the unit vector, which will give you these. Correct. Right? Now, I said, show the God, and our church is burning. The magnitude of that force is 51. The judge. Judges, this is for you. What's the step? Also, you guys can love the judges. Yes, sir? Okay.
Get it to her.
Truth number 11. Just call yourself a boy. That's how you prove it. Right? Whenever they say judge, because you're burning with this question, whenever they say show, something is this. You need to know the theory behind it. Show that two things are parallel. What two lines are parallel? What is the properties of parallel lines, right? That's the only thing you have to know. Simple, right? This is just for you to know that this answer is correct, right? If you don't get 51, you get 51 point something. Okay, it's fine. It's a matter of saying you did a lot of blunders there. It's like a proof. You're proving, right? After getting your answer. Why? Now number 2. This one here. What is this? What's that?
That's the unit. That's not the proof.
You can remove what's this for now. Tell them what is this. Okay, here they found vector AP, right? Right? Oh, they're not sure what they were doing. This is vector A, right? That's a penalty. Another penalty is that they don't know what they're doing. You got it right. But you can here now after that they find the unit vector of AP. But they're not even showing what is this. Another penalty. You're scoring with this penalty. But penalizing them doesn't give you a point. So it means you are missed. Now here, they said the magnitude of that force multiplied by the unit vector. Right? Then they got this, right? Then they ask us a question. What is this? It's a penalty for you guys. Because this is the answer. It's correct. That is your force. So the question was, how do you get that force? Now, you guys did everything correct, but you're not sure. Why? Because you forgot one thing. The unit vector of a force is the force, right, over. Oh, let's write it so that you guys will not get confused. Right? It's the force itself divided by its magnitude. Right? The force with its components divided by its magnitude. You get the unit vector. And we said vectors in the same direction. That was the key item. Vectors in the same direction have the same unit vector. Just for interest's sake, you can do it quick if you're quick. The magnitude of unit vector AB. Give me a quick answer. Don't even have to punch your calculator. Group number 11. It's 1. That's 20 points to proof number 11. So far they are ranking number 1. Disagree, agree, fail to disagree, still thinking, punching the calculator, not sure. Because it's 1. You don't understand it? Oh. Anyone doesn't understand it? Yes, listen. You don't understand. How do you find the magnitude of a vector? Right? Let's come here. This is the unit vector AB. Right? And we want to find the magnitude of AB. Right? Then how do you do it? It's a 3D, right? So we have A squared plus B squared plus C squared. Now the coefficient of your I or your X component in the unit vector is what? Is minus 8 over 9 squared. The coefficient now of your J, which is your X component, is minus 4 over 9 squared. The component or the coefficient it's minus 4 over 9. The coefficient of your Z or your K component is 1 over 9. Punch in your calculator. And what do you do? You get me? 1. Hence, unit vector is a special vector, whereby its length is 1. We just proven that. And it's 1, right? What about this one then? It's the same thing. The magnitude of the unit vector BA. What is it? Quick proof, come on, any proof? Yes, proof 3, ne? The same? It's going to be what? It's 30. I was going to say it's 10 points because it's a lucky guess. Because whenever they say answer quick and the unit vector of AB, if we said answer quick, it was 1. Then for this one, they say, okay, answer quick, 1. It's wrong. Then the other guy, answer quick, it's 0. It's 1. You can prove it. Right? How will you prove it? Same procedure. Coefficient of your I squared, coefficient of your J squared. In this case, it's 2D because your K component is 0. We're all happy with that one, right? Now let's look at number 3, which everyone was passing on and selling in. Group 11 sold number 3 to Pro. They sold it, they sold it, they sold it. If you look at number 3, my judge there will tell you we didn't sell. Yeah, it's a good thing because you guys don't have to sell it. Right? Can anyone tell me in one way what is number 3? Why did they put number? Let's try to think about the whole exercise. Why did they put number 3? Group 11, this is your baby. Let's work on it. Tell us, after you've done it, what did you realize? Group 1? Not sure. Okay, careful. 2? 3? Okay, you count right there. Group 2? What did you learn from number 3? You can't take that as a lesson. Yes, sir, yes. And what did you learn? What did you learn? What did you learn? Group number 11, what did you learn? Yes, guys. I need us there. Guys, let's read it. Determine the resultant force. F1 plus F2 plus F3 plus F4 of the following forces. All you have to do is to add force number 1, force number 2, force number 3, force number 4. Right? Force number 1, force number 2, force number 3, force number 4 gives you the resultant force, right? From mechanics. But here we'll do it the algebraic way, right? Force number 1 is given. We have it, right? Force number 1 is given. Let's look at the second statement of the. They said, right? Let's have another clue to tell us. Are we seeing a ghost there? Group number 7. Group number 7 has already got the final answer. Group 7, I'm talking about you. You should concentrate. I can say something really wrong about you guys. Group number 7 has already got the answer. Right? But group number 7, what is F2? Because group number 1 up to group number 12, except group number 7, is saying what is F2 or the force 2. What is it? It's what? 24I plus 10K. Are we all happy with what we see there? Good question. That's what I was wondering. I wanted you guys to ask. How did you do number 1?
Number 1.
Yes, keep level.
That's all. It's going to be
Are you telling us the steps? Right?
yes.
Thank you. You guys are sitting with 20 points, right? Plus these ones. It's gonna be
The 2
vector F2
equals to the magnitude, which is 26 times 12I plus 5K.
divide by the whole thing.
No, only the one that. Oh.
What's the difference between
Not the whole.
and what's the difference between the two? The moment you multiply,
Oh.
okay, let's say Joy.
12 squared plus 5 squared.
We simplified it. Are we together? Let's put it in a simpler way. All he did was to say now, you are given a force and its magnitude. You are given the direction. It's the same as saying a force F2 of magnitude 26 is in the direction of 12I plus 5K. So what's the first thing you do? Find the unit vector of the direction vector you are given. Right? Unit vector of the direction vector. Let's call that direction vector D. Right? It's gonna be where D is 12I plus 5K according to direction vector. Direction vector over the magnitude of the direction vector. Right? Which is 12I plus 5K, all this over the magnitude, which is there. Right? Now, looking at these, this is there. Right? And from what we said unit vector of F2 will be the same as the unit vector of D. Why? They're in the same direction. Now, we know the unit vector of D is given as this, right? And that is given as that, right? Now, unit vector of F is going to be the force over its magnitude, which is equated to the direction vector over its magnitude. Make F the subject of the formula. Cross multiply, you get F multiplied by that, and you get this, right? Still, the force is not the subject of the formula. So this yields to divide with the magnitude of the both sides. Call this F2. F2 is the magnitude of the force multiplied by the over. In this formula, you use the dot. Straightforward, put in everything there and get the answer. So number 3, what you can learn from number 3 is that you're doing whatever you did in 1 and 2 3 times. Maybe that's why you made it number 3. Because you're doing it 3 times. You have to do it for force number 2, force number 3, force number 4. That makes it 3 times. It means from group 11, there's 4 members of group 11. One member doesn't have to find the force. It's given. Lucky member. Another member has to find the force. F2, they found it. Another member has to find force 3. Another member has to find force 4. Now they have to come with their answers and add them. How do you add? Let me show you how you add. Let's say you want to say F2 plus F1. Right? You're going to add the like terms. The I with the I, the J with the J. 24 plus 1J, 25I. Sorry, 24I plus 1I is 25I. 10K, 1J minus 1J plus 0J is minus 1J. 3K plus 10K plus 18K. That's how you simply add, right? See the time. Since we guys did, that's it, guys, around unit vectors. Around unit vectors, there's no key. That's it. You're given a force, you're given a vector, and you're given the magnitude of a vector, and that vector is in the same direction, that's another magnitude, that's another vector. So the trick here, guess what they do? It's a two-way. This is how the question comes. In terms of the given data. To conclude on this one, you'll be given these. So you'll be given the magnitude, right, of, let's say, vector A, right? Given a magnitude of vector A, and in direction of another vector, right? Magnitude of vector A. And you are given another vector with components, say vector B. Right? So here's how it's given. You are given a vector with its magnitude, but not its components. Right? And you're given another vector, and they give you its components, and they tell you it's in the same direction as the vector that's given only the magnitude. Right? And they tell you to find the vector that they've given you its magnitude in terms of vector form, meaning in terms of its components, right? The first thing you need to know, same direction. Keyword, they're in the same direction. Hence, unit vectors, the same. So you find, you can't find the unit vector only having a magnitude. You need its components, right? So you find the magnitude, the unit vector of the vector that they've given you its components, right? Which is what we did there, right? You're given this unit, this vector, in terms of its components. The force was only given 36 Newton, no components with it, right? So what we do, we find the unit vector of this one. Since we have the components, we can find the unit vectors and the magnitude, right? Find the unit vector. Then we come here, we find the force, right? To prove that this answer is correct, we find the magnitude of the force, and we got 36. That's it. Any questions? Any question when say, what if it comes like this, the question? What if there's no other angle? Any questions? Yes. So the answer is, it's simple, right? Okay guys, it did scalar. Let's see it. Using scalar product. What is the properties of parallel vectors? Taylor? Okay, same gradient in terms of vectors. Okay, we have same direction. Another one. You can cheat this.
Scalar multiples of each other.
Yes, they are scalar multiples of each other. Right? Perpendicular vectors. Yes, sir? Ah? Scalar perpendicular vectors, they are zero. Yeah? I want you to be sure.
Zero.
What is zero? Can you write it? Can you come and write the scalar product? Just say it's vector A and B. I'm giving you vector A and B. Group number 8. Can write it. Yeah, it's gonna write. Yes, sir. Yeah, let's have a question on number 2.
Yeah. In the book, it's kilonewtons. Aren't we supposed to
Good question. Ah, guys, what is this? Anyone who can identify that? Okay, before you identify, let's have this question. In number 2, H, we are given, okay, H, you want to correct it? Yeah. Go. In the question on number 2, we are given the force as 36 kilonewton. Right? Question is, why are we not writing, what's the question? Why are we not substituting 36 times 10 to the power million? To the power 3. Let me tell you something, guys. Let me tell you something. Right? We're doing maths, right? But guys, do maths, but we relate it to other concepts. For instance, related to mechanics, physics, and all those things. Never worry about what's the given SI unit. They can give you giga Newton. Don't worry. They can give you a force and say now the magnitude of that force is 30 micro newtons. You see this? SI unit makes no difference to what you're doing. Can anyone give me a reason why? And I'll give you 50 points for your group. Why am I saying the SI unit has no effect?
No defect.
Yes,
Probably
effect.
because all the vectors have the same, all the vectors might have the same unit, so it's pointless to change.
Okay, all the vectors might have the same unit. I'm thinking about it, processing it. Another one. Last one.
The direction
Direction might be opposite directions. Another one. Even if you can change units, the size is still the same. Even if you can change units, the size is still the same. The 50 point, going once, going, yes.
because they are all vectors.
Because they're all vectors. I have all these answers. Yes, sir. Why? Use it. Use it. You don't want the 50 points. Why? Guys, let's look one thing. Yes. We know it.
It's not specified to use to another
Okay, not specified. Okay, let's also note one thing. Another one.
Is it the question is
Why the SI units have no effect?
because they didn't give us a this unit. It's whatever it is.
Also take that and process it. They didn't give us an SI unit. It is. Guys, let's just look at it. Let's look at it. Okay, they give us now. So we're saying they gave us. Okay, guys. Sometimes they give us, sometimes they don't. It's fine. Yes. Math, it doesn't matter. I take that and process it. Yes, it's true. It doesn't matter what the SI unit is giving us. Why? We're dealing with points, right? Dealing with this, and this is a vector, right? Right? Whenever I said calculate the magnitude of this vector, you never use 10 times whatever, 10 times whatever, right? So these are points on a Cartesian plane, right? Where it has x, y, and z. They didn't tell you the scale is kilo, right? So SI unit, just take it and store it elsewhere. And you know that whenever they ask you to find, let's say, the magnitude of the force, you take whatever SI unit is given and put it there. If it's given in millinewtons, take it, millinewtons, put it there. If it's given in able newtons, put able and newtons. Doesn't matter. Banana newtons, banana and newtons, right? Don't stress and say, what is one banana in 1 newton? Right? Because it has no effect. Right? Don't worry what is 30 minus. No, it's not your problem. All you need is these. The SI unit, it's there. We say don't forget it because it's given. Right? So don't worry. Number 1 and number 2, they're the same. Just like you saw kilonewton. Kilonewton had no effect. The points that were given, they didn't give you the points between A and B as kilo and whatever. So take the magnitude. Don't look at the SI unit. SI unit, why is it there? To make it to have sense, right? Because now when you calculate force, and you just write 30 or 36, and someone tries to read whatever you've written, someone from Germany or wherever, doesn't know what you are calculating, right? SI unit, you put it so that it's understandable. But the answer is 36. Are we all happy? Are you answered?
Yes.
With that being said, let's have a quick exercise, which is a battle between the features, survival of the features group. The final battle, page 11 is the final battle. Survival of the features. Each and every question has about 20 points. You guys can have, and we'll rate the groups. You guys know you're sitting at 0 now. Even those ones who think they got 20 from those ones, they're still sitting at 0. Yes. Exercise 3, page 11. Here's how it's going to do. It's going to work. You try to answer number 1 up to number 8. Number 1. With number 1, here's what I will do due to the time page. Each and every group, our question says, determine the scalar product. So what did they want to put there? Give me 1 and I'll give you a point. Yes? Multiplication sign. Multiplication sign, minus 10 points. Yes. A dot. Why? Because they said, read the question, determine the scalar product. It's a dot product. So cross product minus. That's what it's there for. It is not a multiplication. No. No. It's a dot product. It's a dot. It's a multiplication. Yes? Yes? Guys, here we're not doing 2 times 2. We're doing a vector dot by a vector. A vector dotted with a vector. Right? This is not a multiplication sign. What is the product? A product. It's after I've done multiplication. But now we are doing it in terms of naming. Which means that dot there. No, you're gonna confuse it. Okay, let's have this. Sweat 50 points, guys. Question is it the same as? That's the question. That's the question. But now look at it mathematically. Let's look at it mathematically. This is a multiplication sign. Look at it. This is not x looking somehow. This is not x looking. This is a multiplication sign. Right? So if I say that's a multiplication sign, am I saying the correct thing? So this. Are they the same? No. They're not the same, right? Why? That's it. This is scalar product. This is scalar product. This is vector product. Dot product. Oh, cross. That's not a multiplication sign. That's a cross. So now that's a difference. Are you happy there, my friend? Now you're seeing 2 things. One is a vector, the other one is a cross. So now that's a difference. Are you happy there, my friend? Now you're seeing 2 things. One is a vector, the other one is a cross. So now that's a difference. Are you happy there, my friend? Now you're seeing 2 things. Sometimes we call it the multiplication sign. Now we call it a cross. No, it's only in vectors we call that thing a cross. It's a cross product. It's a dot product because there's a dot. Right?
So when substitute we use
Why are we saying product? Ne?
Is it dot? We use a dot with scalars and we will use a cross for vectors.
Guys, let's begin. We use a dot to indicate it's a dot product or a scalar product. We use a cross to tell you now we're doing a cross product operation, right? This is just indicating an operation. Why am I saying that? Remember what we say the dot product is. We said it's W1. Okay? Oh, you can say now it's A1 times B1 plus A2 times B2 plus A3 times B3, where A is A1 I plus A2 J plus A3 K. P is B1 J plus B2, no B1I plus B2J plus B3K. Right? So guys, looking at the two, right? If you'd substitute these two here, right? And it now there's a thing. They say multiply. Can anyone do a multiplication of that? Do a multiplication of what I've written using your basic maths. Using your basic maths. Just indicate with whatever indication, a simple indication what you're going to do. Let's say, come forward. Then you're done. Okay, let's say you're coming from Metric. Just got here to university. Were you gonna do that? No. On an honest note. Let's get someone who's gonna be honest. Penalization for not being honest. Dishonest. Dishonesty, that's a penalty. What are the judges saying? Let's get someone who's gonna be honest. How you were honestly gonna do that? Pretest number one, they gave you that. What were you gonna do? Yes? What were you gonna do? First thing. Yes, tell me.
Okay, so it's A1.
Yes?
No, not A1. Okay.
This one?
Yeah.
Multiply by what?
B1.
Yeah? And?
Plus.
Be honest. Plus? Okay, oh yeah.
So it's
Plus? Multiply by B1 plus? Plus?
A2.
Okay, let's have someone who's honest, guys.
Okay, then A1. B2. Plus A1 times B3. Yeah. And then I2. But that's
thank you. So this is not multiplication. If you had to multiply, this is what you were going to think, right? But the dot product is not defined as such, right? It's defined as A1 times that and A2 times B2, like he did it, because now he knows, right? That's it. So you don't call it multiplication, because the operation we are doing there is not the multiplication operation, the one we know, right? We're doing the dot product, defined as that. Your I with your I, with J with your J, K with your K, then you add them, and you get the
So basically dots and times.
yes?
Dots, not both dots and times are two separate.
Thank you. The dot and times or multiplication in maths, they're the two different things.
When you multiply, do you keep your I, J, and K? Or what?
Like how?
So it's a dot product,
Yeah.
and it's P, vector P and vector Q. It's 9.1.
It's here.
Yeah. So not
9 point.
9.1.
Page what?
Okay. Small or big thing.
Guys, let's look at page 10. Your question is
9.1.
9.1. What's your question?
Okay, it's giving us a measure there.
Yes.
So this is the dot product of P and Q equal to AD
Yeah.
plus BE plus CF. You don't have to write the RJK.
Yeah. When you do the multiplying out of the, when you get to do your dot product operation, you don't use your, just know, you use the IC to identify the components of the that are lying on the same axis, right? So your dot product, since it's a scalar, right? We only take the coefficients, which is A1 times B1 plus the coefficients A2 times B2, right? Plus EB times B3. And when you add all those, they will give you a scalar product.
Okay, so scalar product is
Understand? Any more questions? Questions?
the answer to
Clarity? Clarity?
The answer for exercise 3, 1.1.
Have you started with exercise 3 though? You guys started? That is number 1.
What's the answer?
What's the answer for number 1? Minus 9. 1.2.
It's
1.3. Let's look at number 1.3. What did you get? 1.3.
Yeah.
Guys, number 1.1, number 1.2. I see you guys are not having a problem. Or is there anyone having a problem with 1.1 and 1.2? Huh? Anyone having a problem? Okay. Nobody has a problem with 1.1 and 1.2 and 1.3. 1.3. Let's see 1.3. 1.3, they said find the dot product of that. They give you P and Q. Now, there's a follow-up question after that. That's where the problem is, right? Before that.
There's no J. What do you do?
What is the J here? 0, right? So the same as 0J plus 5K. 0. So the answer is